Let's go and review all the things we have learned about how to graph a function. Um, so we'll call this curve sketching. Now, there's a couple steps. I have 7 steps that you should go through when you sketch. The first thing you should do is define the domain. And this means that you can't have, let's say you have a square root and you have an expression inside the square root. Well, that means that the expression inside there has to be greater than or equal to 0. It has to be positive inside a square root, or your denominator cannot be 0. Those are the two, pretty much the two things we look at. And when we look at logs and exponentials, there'll be different domains. But for right now, those are the two things we look for. Then we find the intercepts. To find the x-intercept where it crosses the x-axis, you set the expression equal to 0. If you want to find the y-intercept, you substitute x equals 0 into the problem. And that's where it crosses the y-axis. Then you have asymptotes if it's a rational function. And again, later on, logs and exponentials will be different. But if you have a rational function, which means you have a polynomial in the numerator and a polynomial in the denominator, then you're going to have an asymptote. If not, then you can skip that step. Then you find y prime and set it equal to 0, or find out where it's undefined to get the critical points. And again, these are points in the domain. These points have to be in your domain, or else you don't look at them. Well, this isn't a separate step. Well, yeah, let's make it a separate step. Finding the second derivative, set it equal to 0, or find out where it's undefined, gives you the possible inflection points. Again, these have to be in your domain. And then we make a chart. Now, my chart is different than the chart in the book, but I like it because it gives us all information in one chart. And to do this, to get the chart, you test around any vertical asymptotes, critical points, or possible inflection points. So when you put those points on your chart, that's what you need to look around. So here's your number line, and then you do y prime y. That tells you if y is increasing or decreasing. Y double prime, that tells you if y is concave down or concave up, and then the shape of the graph. So you have 4 shapes that possibly could happen. And the first one is increasing concave down, then it's decreasing concave down, then decreasing concave up, and increasing concave up, because you always move left to right. And then you substitute the critical points and the possible inflection points into y, into the original problem, and this gives you the points to plot on the curve, besides the intercepts. Okay, so let's try an example of all this, put it all together. Again, this is just kind of a review of everything we've looked at. And the first example, let's try a difficult one, is that, so the first thing you do is find the domain. Now inside here has to be positive. So 3 minus x has to be greater than or equal to 0. It could be 0. So 3 is less than or equal to x, or x has to be less than or equal to 3. So that's our domain. Everything to the left of 3. Then we check our intercepts. Our y-intercept is when x equals 0, so that 0 times the square root of 3 is 0, so 0, 0. And our x-intercept, setting this equal to 0, is going to be x equals 0 or 3. So we have 0, 0, and 3, 0. That's where it crosses the x-axis, and that's our y-axis. Okay, so we're getting a lot of information already. There's no asymptotes because it's not a rational function, so we can skip that step. Now on to the good stuff. The y prime, you're going to have to use the product rule. So it's first times the derivative of the second, and I'm using the superpower rule, plus the second times the derivative of the first. Now when we do this, we always factor out the lowest power of x from these two. So I factor out a negative 1/2. I'm left with a negative 1/2 x, so I have this left, and this left. Now over here, I have to decide how many of these. So when you add exponents, because when you multiply you add exponents, equals a half, and that's going to be a whole number, 1. Negative a half plus 1 equals a half. So remember, when you multiply them back out, you add exponents to get that other exponent. Okay, so if I simplify the inside of those parentheses, I'm going to have 3 minus 3/2 x over the square root of 3 minus x. And when I set that equal to 0, I get 3 equals 3/2 x, or, x, that means x equals 2. So that's a critical point. And it's undefined at 3. So there's a vertical tangent line at 3, and a critical point, there's a horizontal tangent line. So that helps us for the test. Wherever y prime is undefined, you have a vertical tangent line. Okay, y double prime is going to be, let's use the quotient rule. Well, let's do the product rule. This is really, y prime is 3 minus x to the minus a half times 3 minus 3/2 x. So I'll use the product rule. It's the first times the derivative of the second plus the second times the derivative of the first using the superpower rule. Okay, I take out the least, so I'm going to pull out to the negative 3/2 power, and that's going to give me, I'm going to need one more of these so that when I add those together, I get negative a half. Remember, when you multiply, you add exponents. So I need one more of those, and I need a negative 3/2. I've already taken it out of here, so I need a 3 minus 3/2 x, and then I need a minus a half times a negative 1 is a half. Okay, so I have to simplify that. So that's 3 minus x to the minus 3/2. Again, I picked a more difficult problem just so you can see this. I do the same steps. So inside here, I have minus 6/2, which is minus 3. And that can be 6/4 minus 3/4 is 3/4 x over 3 minus x to the 3/2. So if I set that equal to 0 to get the possible inflection points, I have 3/4 x equal 3, so x is 4, and it's undefined again at 3. So this is a possible inflection point. All right, let's put those on a number line. So I need to make our number line. Let's do it on the next page. I'm only defined to the left of 3, so I don't need to do anything over here. So I'm going to test. Let's see, what did I... Okay, let me go back to this. 4 is not in the domain. So we don't even have to test around. We can't test around it. Okay, and I saw that when I was doing the number line, I have to keep an eye on my domain. Okay, here's my number line. So the next number is 2 is our only critical point. So let me test 0 and 2.5. So if I test 0 in the first derivative, let's go back and see what the first derivative was. I test 0 in there, it's going to be positive. And I test 2.5, it's going to be negative. So it's increasing, decreasing. If I test 0 in the second derivative, let me go down here. Right here, I'm going to get a negative. And 2.5 in the second derivative. I guess I should have written out what my derivatives were. This isn't cooperating. Okay, that's going to be positive. No, it's going to be negative also. Let me try it again. So it's negative. I'm plugging 2.5 into the second derivative. So it's negative. So it's concave down, there's no inflection point. So the shape's going to go like that and then like that. So when we graph it, we know 3, 0 is an intercept, 0, 0 is an intercept. We need to find step number 7 is, I guess I'm not numbering the steps, so is to plug the critical point into the function. So that's going to be 2 square root of 3 minus 2 square root of 1 is 2, so it's 2. So at 2, I'm going to get 2, 2. This is 3, 0, and this is 0, 0. So the only thing we can do is kind of go like this. And that keeps going down. So that's what the graph of that looks like. Okay, let's try another one. First thing you do is find the domain. Here, you can't have x squared equal to 0. You can't have your denominator equal to 0. So that means x can't be 0. So our domain is negative infinity to 0 or 0 to infinity. It's everything except 0. Our intercepts, if I set y equal to 0, remember when you set a fraction equal to 0, you only set the numerator equal to 0. 0 over anything is 0. So that's x equal 1. And if I plug in 0, it's undefined. So this tells me that 1, 0 is the x-intercept, and there's no y-intercepts. Now here I have asymptotes, because it's a rational function. So my vertical asymptote is where my denominator is 0, and my horizontal is when I take the limit as x approaches infinity. I divide everything by x squared. I have 1 over x minus 1 over x squared over 1. Okay, that goes to 0, that goes to 0. Since my denominator is getting larger, 0 over 1 is 0. So my horizontal asymptote is y equals 0. And my vertical is x equals 0. Okay, now I'm ready to take the derivative. I have to use the quotient rule. It's going to get rid of 1, that's going to get rid of that, and that's going to get rid of that. So that's going to be x minus 2x plus 2 over x cubed, which is 2 minus x over x cubed. So x equal 2 is a critical point. 0 is not a critical point because it's not in the domain. Second derivative, quotient rule again. Derivative of the numerator is just negative 1. Again, I'm going to take away 2 of those. So this is going to be negative x minus 6 plus 3x, which is 2x minus 6 over x to the 4th. So the possible inflection points is 3. Again, 0 is not in the domain. So I have my points. Now I make my chart. I put 0 as my asymptote, vertical asymptote, 2 and 3. I'm going to test negative 1, 1, 2.5, and 4. I'm plugging them back into the first derivative. When I do that, this will be negative, positive, negative, negative. So it's decreasing, increasing, decreasing, decreasing. Now I take those numbers and plug them in the second derivative. It's negative, 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 positive, concave down, concave down, concave down, concave up. So decreasing, concave down, increasing, concave down, decreasing, concave down, concave up, decreasing. So that's the shape. Alright, now all I have to do is get my points. Plug in 2 into the original problem. Plug in 3. And let me just see if I can put this in here. This is a vertical asymptote. This is the horizontal asymptote. At 2, I get a 4th. And at 3, I get 2/9. And since this is the asymptote, it's concave down till you get to the asymptote. I think I have another. I have an x-intercept at 1, 0, so I have that point. So it does cross the horizontal asymptote, so it's concave down until it gets to 2. And then it's concave down until it gets to 3, and I'm just connecting the dots, and now it's concave up. That's an asymptote, so it follows it. Okay, so this is 1, 0, this is 2, a 4th, and this is 3, 2/9. Okay, so if you do all those steps on every single graph, you can't go wrong. You just have to be careful that you take your derivatives right.